All right, so guys, this is a problem out of 11.4, and it says two coins are tossed. Assume that each event is equally likely to occur. So part A says, use the counting principle to determine the number of sample points in the sample space. Okay, so remember, we're going to toss two coins, right? So the first time when we toss our coin, it could either be heads or it can be tails. So we have two choices, right? Let me fix this. Here we go. Okay, choices. There we go. Okay, then this is the first coin, right? And then the second coin, we can still get either heads or tails. So we still have two choices. That looks better. And so our sample space, what we're going to do, we're going to take those numbers and we're going to multiply them, and we're going to end up with 4. So for my first answer for part A, we're looking at 4. Okay, now part B says, let's construct a tree diagram and list the sample space. Okay, so when we're going to do our tree diagram, remember, we're flipping two coins, right? So when we flip the first coin, our choices are heads or tails. Those are the two possibilities that we can end up with. Now, when we flip the second coin, suppose when we flip the first one, we landed on heads. Now, when I flip the second coin, I can land on either heads or tails again, okay? And if I would have landed on tails and I flipped that coin, I can still land on either heads or tails. So this is what my tree diagram is going to look like. And then there's a second part to it. It says we're going to list the sample space. So what we mean by that is, remember, we said we're going to have a total of 4 choices, right? So the first time we flip our coin, we can get heads, and then we can get another heads. Or we can get heads and then tails, or we could have gotten tails and then heads, or we could have gotten tails and then tails. These are our 4 possibilities here, okay? Now, part C. Part C says, let's see, determine the probability that no tails are tossed, okay? So I'm looking at, these are my 4 choices, and I want to figure out of those 4 choices, which ones have no tails? This one right here, right? So for part C, which says no tails are tossed, okay, there was 1 out of the 4, okay? Now let's do part D. So part D says, what is the probability that exactly 1 tail is tossed? So what I'm going to do is I'm going to look over here. Which one has exactly 1 tail? This one does, and so does that one. So out of the 4 choices, 2 of them have exactly 1 tail. We can reduce that fraction to, it looks like a Z. It's supposed to be the number 2. So 1 over 2, okay? And then we have a part E. So let me come back. So part E says, what's the probability that 2 tails are tossed, right? Where's my pen? Here we go. Okay, 2 tails are tossed. So again, I'm looking at my 4 choices here, and the one that has 2 tails is this one right here. So again, out of the 4 choices, 1 of them has 2 tails. And then there is a part F. So let me come back over here. Part F says, determine the probability that at least 1 tail is tossed. So think about what at least 1 means. At least 1 means 1 or more. So this one has 1 tail. This one has 1 tail. This one has 2. So that's still going to be at least 1, because at least 1 means 1 or more. So out of the 4 choices, we have 3 that have at least 1 tail, okay? So these are my answers for my parts A, B, C, D, E, and F. Y'all got any questions? Let me know. I'm happy to help.